Welcome to Deep Space Explained, the channel where we journey across the cosmos from our planetary backyard to the most distant edges of the universe. Here, we unravel the mysteries of space, time, and everything in between, with science, storytelling, and a touch of cosmic wonder. 40 light-years away, orbiting a faint red star, lies a world that could forever change humanity's understanding of the universe. This is TRAPPIST-1e, a rocky exoplanet, so Earth-like in size and conditions that scientists have long suspected it might be one of our best chances of finding life beyond Earth. And now, thanks to the James Webb Space Telescope, we may finally have the first clues: a nitrogen-rich atmosphere, stable enough to hold water in liquid form. Join me as we journey across space and time to uncover what TRAPPIST-1e really is, what Webb has revealed, and why it might be one of the strongest candidates for life outside of our solar system. Stay with me, because this story is about more than a planet. It's about us, our future, and the eternal question: are we alone? Let's start with the bigger picture. 30 years ago, astronomers discovered the very first exoplanet orbiting another star. Since then, the number has grown into the thousands, but most are gas giants, frozen worlds, or planets orbiting too close or too far from their star. The Holy Grail has always been to find another Earth-like world, rocky, temperate, and capable of sustaining water and life. And among all these candidates, TRAPPIST-1e has consistently stood out as one of the most promising. Why? Because it isn't just another rock in space. It's the right size, in the right place, around the right kind of star. A planet that whispers to us, "I could be alive." To understand TRAPPIST-1e, we need to first understand its star, TRAPPIST-1. This is a tiny, ultra-cool red dwarf, only slightly bigger than Jupiter. It shines faintly compared to our Sun, but burns with incredible stability most of the time. Around it orbit 7 rocky planets, all discovered in 2017. Astronomers were stunned. An entire family of Earth-sized worlds, packed tightly around a single small star. Among them, TRAPPIST-1e sits in what scientists call the habitable zone, the distance where temperatures could allow liquid water to flow on the surface. It's like the Goldilocks story: not too hot, not too cold, just right. TRAPPIST-1e is almost exactly the size of Earth. Its mass suggests a rocky composition, with gravity very similar to what we feel here. This means, if you stood on its surface, you would feel nearly the same pull as on Earth. Not floating away, not crushed down, just right. Its orbit takes just 6 Earth days to complete a year. Imagine birthdays every week. But despite its short orbit, the weak red light of its star means the temperature could be mild enough for oceans, rivers, and clouds. In fact, many astronomers now consider TRAPPIST-1e the most Earth-like exoplanet we've ever found. Enter the James Webb Space Telescope, humanity's most advanced eye in the cosmos. Unlike Hubble, Webb can detect faint infrared signals, perfect for studying distant planets. When TRAPPIST-1e passes in front of its star, starlight filters through its atmosphere, leaving behind a kind of chemical fingerprint. This technique, called transit spectroscopy, allows Webb to decode the gases surrounding the planet. And the first hints are thrilling: the presence of nitrogen, the same gas that makes up most of Earth's atmosphere. Why does this matter? Because nitrogen is stable, protective, and the foundation of an atmosphere that can support life as we know it. On Earth, nitrogen makes up nearly 80% of the air we breathe. It doesn't react wildly, which means it provides a safe, stable background for more reactive gases like oxygen and carbon dioxide to exist. If TRAPPIST-1e has a nitrogen-rich atmosphere, it suggests stability against solar radiation and the possibility of a working water cycle. Rains, clouds, maybe even oceans. In short, Nitrogen doesn't prove life exists, but it makes life much more likely. It's the canvas on which life's painting can emerge. Water is life's universal ingredient. Without it, life as we know it cannot exist. Webb's data hints that TRAPPIST-1e could sustain liquid water. Not frozen into ice, not boiled away into steam, but flowing, moving, alive. Think of Earth, from the deepest ocean trenches to the highest mountain lakes. Wherever water exists, life finds a way. If TRAPPIST-1e holds oceans, they could cradle ecosystems we can barely imagine. Alien, but perhaps not so different from the beginnings of our own world. But it's not all good news. Red dwarfs are notorious for violent stellar flares, bursts of radiation that can strip atmospheres away. TRAPPIST-1e may face this constant bombardment. Without protection, its air could be blown into space. So the question is, does TRAPPIST-1e have a magnetic field, like Earth, to shield it? If it does, life may survive. If not, the planet could be a barren desert, a tragic reminder of what might have been. Assume TRAPPIST-1 holds on to its atmosphere. What would life look like there? The star's light is not yellow, but a deep, dim red. Photosynthesis, if it exists, might evolve differently. Plants, if they exist, could be black or dark purple, absorbing as much light as possible. The planet may also be tidally locked, with one side in eternal daylight, the other in endless night. Life might thrive on the twilight strip between them, the so-called Terminator line, where conditions are balanced between fire and ice. Imagine alien forests stretching across a perpetual sunset, a haunting, beautiful world. The Webb's next mission is to search for biosignatures, chemical signs that could only be explained by life. On Earth, oxygen, methane, and ozone all point to biology. If Webb finds similar combinations on TRAPPIST-1e, it would be the closest we've ever come to detecting life beyond Earth. But it's a delicate task. Abiotic processes, non-living chemistry, can mimic some of these signals. That's why scientists need patience, repeated observations, and cautious analysis. But make no mistake, we are closer than ever to answering the question of questions. Why do we care so much? Why pour billions into telescopes to study a planet 40 light-years away? Because finding life elsewhere would change everything. It would prove we are not unique, not alone, not the only story the universe has written. Since Copernicus, Galileo, and Kepler, humanity has slowly accepted that Earth is not the center of the cosmos. TRAPPIST-1e might be the next step in that journey, showing us that Earth is not even the only cradle of life. James Webb is just the beginning. The next generation of telescopes, the extremely large telescope, the giant Magellan telescope, and future space observatories like HabEx and LUVOIR will sharpen the view. One day we may capture a direct image of TRAPPIST-1e, seeing its clouds, oceans, or even signs of vegetation. That moment would not just be science, it would be history. Of course, 40 light-years is unimaginably far. With today's technology, it would take hundreds of thousands of years to reach. But theoretical projects, like Breakthrough Starshot, imagine tiny probes propelled by lasers, racing at a fraction of light speed. Perhaps in a century or two, a probe could pass by TRAPPIST-1e, sending back the first close-up photos of an alien Earth. It's a dream, but so was Webb once. Dreams have a way of becoming real. TRAPPIST-1e is more than data, more than numbers on a chart. It is a symbol of human curiosity. It reminds us that while our world feels vast, it is just one among billions. For every TRAPPIST-1e, there may be 100 more waiting, each with its own story. The search for exoplanets is not just about finding life. It is about finding meaning, our place in the cosmic ocean. So what does TRAPPIST-1e tell us? That we live in a universe filled with potential, that we are only at the beginning of discovery. If nitrogen, water, and stability truly exist in this world, then life may not be rare, it may be everywhere, hidden just beyond our current reach. Perhaps in the next few decades, we will finally have the evidence we've been searching for, proof that Earth is not alone in nurturing life. TRAPPIST-1e is not just another exoplanet. It is a beacon, a reminder that the cosmos is alive with mystery and possibility. And the James Webb Space Telescope has only just begun its journey of revelation. If you found this exploration fascinating, join us here on Deep Space Explained for more journeys into the unknown. Because the universe is vast, our questions are endless, and together we will keep searching for answers among the stars.